மாணவர்களின் சிந்தனைகளை வடிவமைக்க SNS இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் தனித்திறமைகளை மேம்படுத்த SNS இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் சாதனைகளை போற்றும் SNS இன்ஸ்டிடியூஷன்ஸ் கோவை.
Hi everyone, this is R.Vijayakumar, Assistant Professor, Department of Electrical and Electronics Engineering. In this video lecture series, we are discussing about voltage transformers. In this voltage transformer comes under measurement and instrumentation subject. So what is meant by voltage transformer? Voltage transformer is nothing but it is a higher rating of sensor, voltage sensor. Normally the voltage sensor will sense the voltage value from the lower voltage value, for example 0 to 300 or 0 to 600 volt, but we need to measure some highest voltage values, for example nearly 11 kV or 33 kV or 66 kV. So in that application we can't directly connect it to the sensors to higher voltage value levels. So we need some kind of devices. That device is called as a potential transformer, PT. So that potential transformer is nothing but it is a miniature model of a transformer. So you know that transformer means it is a static device. It is used to step up or step down the voltage value or a voltage profile without changing any kind of frequencies. So in this application we are using a step down transformers. So in this step down transformer, stepping down the rated voltage value, some measurable values, for example 1 to 11 kV into for example 100 to 300 volt or 100 to 600 volt. So from that voltage output value we are going to calibrate, and then based on the calibration value we are going to measure. So for this examples we have in a 3-phase AC distribution panel. So in this 3-phase AC distribution panel we have a voltmeter and then ammeter. So in this voltmeter it will show that 400 volt here. So 400 volt means, for example normally we are sensing the voltage value. So when I am turning on the switches, so it will sense the voltage value of 415 volt here, but the meter is very small amount of meter. But backside of the meter we have some kind of potential transformer array that is called as a PTs. So the same applications are applied here. For example, this one is for a digital meters. In this digital meter also we have a potential transformer as well as a current transformer also there. So here we are sensing the voltage value is a 400 volt here. So in this 400 volt, for example, in backside of the meter, so this is for the backside of the meter. So in this backside of the meter, we are taking the voltage value from the bus bars. So in that bus bars, we are stepping down the voltage value, for example 11 kV or a 33 kV into 400 volt or a 415 volt here. So in that low voltage value is given, or a low voltage value is feeding to the meter. So in this meter, the ranging is between 0 to 400. For example, normally it is called as a PMIC meter, for example permanent magnet moving ion instruments. So because in this PMIC moving ion instruments only applicable for a AC measurements or a AC power sources supply. So in these applications we are sensing the voltage. So we are not sensing the voltage in a direct manner, so because we don't have any kind of sensors to directly tap into the 11 kV or a 33 kV of high voltage range. So we need to step down the voltage value based on the profile value. For example, when we are handling the safe voltage value 0 to 100 or a 0 to 300 volt. So in this 0 to 100 or a 0 to 300 volt, we are stepping down the voltage value. For example, 11 kV means the output may be a 10 volt. So we are making some kind of calibrations. So when the output will be a 10 volt, it is called as a 11 kV. So when the voltage is going to 5 volt or a 6 volt, it will be a 500 volt. So that kind of calibrations we are making inside the meter. So the meter will easily read the safest value, and also this meter, the human can easily touch the meter, and also the human can work inside in the meter. So when the voltage will be 11 kV or 33 kV, it may get some huge hazards will occur. So but in this low voltage value, the human cannot face any kind of damages or any kind of accidents when we are using a low voltage value. So this is the important thing for a potentiometer. So this potentiometer will help to help measure the voltage value from the bus bars. For example, we are taking a distribution transformer or a distribution panels. So in this distribution transformer we are using 11 kV voltage. In transmission lines means we can use up to 133 kV of voltage value. So in 133 kV voltage value we can't measure in a direct. So because it is a very high pressure or a high tension voltage value. So in this high tension voltage value we can't touch or we can't work or we can't do any kind of work in this distribution side are a transmission side. So we need this kind of distribution panels or a distribution transformers. So that distribution transformer normally called as a potentiometers or a potential transformers. In this potential transformer we have a turns ratio. For example, primary we have 1,000 turns, in secondary we have 1 turns, means it will be have 1,000:1, that means 1 ratio. So thank you for watching. We will see you on a current transformer in next class. Thank you.